Hey there, today we talk about normalization and standardization in machine learning. What is it, what's the difference, and when to use which? So let's break it down. Both methods are extremely useful pre-processing steps or techniques when training models and doing the inference. You take the data, do the pre-processing, usually including normalization or standardization, and pass the data to the model. So let's take normalization first. It is as simple as scaling your data to a specific range. This is great when your data has a lot of variation, like if one column has values ranging from 10 to 1000, while another has values from 0 to 10. For example, the size of a house might be in square feet or square meters, while the number of rooms is, just a number of rooms. So both features are important for, let's say, predicting the price of a house. However, their scales differ significantly. Features with large scale might become dominant in some machine learning algorithms, and to avoid this, we can scale those features to some range. Usually, this range is between 0 and 1. By scaling features, we ensure they're treated equally, so the model performs better. Normalization is pretty simple, as all we need to do is to apply a normalization formula for every feature independently. We take a value, subtract the minimum value of that feature, and divide the result by the difference between the maximum and minimum values of that feature. We repeat this process for every feature value, and we have our feature normalized. When working with image data, pixel values often range from 0 to 255. Normalizing these values to a range of 0 to 1 makes it easier for neural networks to process, and the normalization becomes as simple as dividing each pixel value by the maximum possible value, or 255. This makes all our values fall in a range from 0 to 1. But why use it on images when there is no feature or pixel dominance, you may ask? It turns out there are more reasons to use normalization. Many algorithms, such as neural networks, perform better when features are in consistent and small range. Normalization helps the algorithm converge faster and the training process becomes more stable. Standardization, or z-score normalization, as it is sometimes called, is another way to scale features. So this process centers the data so the mean becomes 0 and scales it so the standard deviation becomes 1. Unlike normalization, standardization does not compress the range of values to a fixed interval, like from 0 to 1. Outliers still exist, but are less dominant, as standardization is less sensitive to outliers. This is done by taking each value of our feature, subtracting the mean value of that feature, and dividing the result by the standard deviation of that feature. We repeat this process once again for every feature value, and we have our feature standardized. But now it's time for the most important question. So when to use which? Usually when doing work, both methods can be used, but there are a few things to keep in mind when choosing. Use standardization if features in your data have outliers, or your model expects data to follow a standard normal distribution. Many algorithms like logistic regression, support vector machines, principal component analysis, they just perform better than data is standardized. And this is mainly because they assume data normality. And also use standardization if you use or try to fine-tune the model that was trained with using standardization as pre-processing step. In this case, use the mean and standard deviation that were used during training. So this ensures that the new images you pass into the model are scaled similarly to the data it was trained on. This is common when using image processing neural networks pre-trained on large open source datasets. Use normalization when dealing with distance-based algorithms like k-means or KNN that are sensitive to scale. When your algorithm expects inputs within specific range, for example, from 0 to 1, or like with standardization, you're using models pre-trained using normalization. I also like to use simple normalization when training CNNs from scratch and with image inputs. Mainly because of simplicity, you only need to divide each pixel value by 255. And this is it for today. I hope you find this video useful, entertaining as well. Hit a like button if you do, and I'll see you in the next one.